Hello again, ladies and gentlemen. This is pre-calc lesson 2. Today we will be learning more on area, cylinders and prisms, cones and pyramids, and spheres. A lot of this lesson is again review of Algebra 2 and geometry, but review is good for the soul. It builds character. So the first thing we will talk about is area. We should know the area of a rectangle is length times width. Sometimes it will be abbreviated. The area of the rectangle is length times width. Again, this should be review. And we also have the area of a triangle is 1/2 base times height. Sometimes we write it as base times height over 2. That's the same thing. Now, cylinders and prisms. A cylinder you can think of a jar of peanut butter or jam or a can of soda. That is a cylinder. And it is a geometric solid determined by two parallel, this symbol means parallel, lines that intersect all the elements of a closed cylindrical surface, aka peanut butter. That is what I think of as a cylinder. We have a couple different kinds of cylinders. We have a right cylinder. A right cylinder, the bases are perpendicular. That symbol means perpendicular. Sometimes we'll write an angle in there as well. And they are perpendicular to the cylindrical surface. What does that mean? That means the bases, meaning the top and the bottom, they are perpendicular. This is a right angle. Here, here. We also have an oblique cylinder. Oblique cylinder means that the bases are not perpendicular to the cylindrical surface. That could look like this. That could be an example. It's a cylinder that is slightly twisted. Now we also have prisms. A prism is when the bases are polygons, not circular. So you could think of a prism as a cube. Ta-da! That is a prism. Now we learn that the volume of a cylinder or a prism, it doesn't matter which one, the volume is the area of the base times the height. This is true of all cylinders. NB. What does NB mean? No buts about it, meaning it is true all the time. Next we have, instead of volume, we have what we call the lateral surface area, often you will see me abbreviate this as LSA, or surface area, I will just abbreviate as SA. The lateral surface area of a cylinder or prism is the area of all external surfaces except the bases. The lateral surface area of a cylinder or prism is the area of all external surfaces except the bases. Now, a fun thing we can do is the lateral surface area of a right cylinder or right prism. Remember, when it says a right cylinder or a right prism, that means that the bases are perpendicular to the cylindrical surface. We can say that this is the perimeter of the base times the height. The lateral surface area of a right cylinder or a right prism is the perimeter of the base times the height. Typically, this is what we will see. We will not see the lateral surface area of non-right cylinders or non-right prisms. We will see right cylinders or right prisms. Now we have our first example. This is example 2.1 in your book, which my book is page 18. Again, that's a second edition. And it says the base of a right cylinder is 10 centimeters high, as shown. This is the base of my right cylinder, and it tells me that my height is 10 centimeters. And it wants us to find the surface area of the right cylinders using centimeters as our units. Hint, surface area is the sum of the area of the base plus the lateral surface area. This is a hint and also an important equation to remember. So let's first find the area of the base. If we look at our base, we can break it up into these two shapes. We have a rectangle and we have a semicircle. And my semicircle, if you can see that there, has a radius of 3. I know that the area of a rectangle is length times width. And I know that the area of a circle is pi r squared, and this is a semicircle. It is half of a circle, so I divide it by 2. Then I will have 30 plus 9 halves pi, which if I make this into a decimal, I get 44.14 centimeters squared. Don't forget your units, for the love of units. Next thing I want to do is I want to find the lateral surface area. We remember the lateral surface area of any right cylinder, we have a right cylinder, is the perimeter of the base times the height. Perimeter, base, times the height. So again, if I look at my base, if I look at my perimeter of my base, I have 5 plus 5 plus 6 for this here. Notice I do not include this side over here. If we look back up at our picture, it's a dotted line, meaning that it is inside of my base and it is not included in the perimeter. So for my rectangle, I have 5 plus 5 plus 6. And then to find the perimeter of a circle, The perimeter of a circle is a circumference, which is 2 pi r, but I divide it by 2 because it is a semicircle. The beautiful thing about that is it cancels my 2's, leaving me with 5 plus 5 plus 6 plus 3 pi, which gives me approximately 25.43 centimeters. This is the perimeter of my base. Now my lateral surface area, this is my perimeter, get correct notation. My lateral surface area is my perimeter, which is 25.43 times my height, and I know my height is 10, it tells me that in the question, which gives me 254.3 centimeters squared as my lateral surface area. I go back to my original equation saying my surface area is the sum of the area of the base plus lateral surface area. So my total surface area is I take the sum of my area of my base, which is 44.14, plus I have to add that again because we know this is a cylinder. A cylinder has both a top and a bottom, the bases. Think of your peanut butter jar. It has a bottom and it has a lid. Those are our bases. And then we also add our lateral surface area, giving me a total surface area of 342.53 centimeters squared. Don't forget your units. This is example 2.1. Let's move on. Now, we will have cones and pyramids as our next section. We remember that the volume of a cone or a pyramid is 1/3 area of the base times the height. If we took a cone and fit it inside of a cylinder, we could actually fit 3 of those cones inside of that cylinder. That's why it is 1/3 of the formula for the volume of a cylinder. The cone has a point, which we will call the apex, is the point of the cone, or we could call it the tip. Again, here is an example. This is example 2.3 in your book on page 20. And it says, find the volume of the cone with this base here if the cone is 6 meters high. So we know that the volume of a cone is 1/3 area of the base times the height. That should be ingrained in your memory. You should be dreaming about it each night. Area of the base. Again, we can break our base into 2 pieces. This is 2, 3. This has a radius of 1. And we can say that our base area is length times width plus pi r squared divided by 2. Notice that I just wrote pi over 2 because we would have 1 squared, which is 1. How handy is that? And this becomes 7.57 meters squared in your calculator. We are given the height up here, so we can just jump straight to the volume of our cone, which is 1/3. The area of my base is 7.57, and my height is 6. Make sure you check that all of your units are the same. Very important. And again, I do this in my calculator, and I get 15 0.14 meters cubed. I will never ever forget my units, and neither will you, I hope. On we go. Now let's look at the surface area of cones and pyramids. We have what's called a slant height in our cones and pyramids. And the slant height is the shortest distance from the apex to the base. The shortest distance between 2 points is a line, and that is exactly what we are doing here. We often call, and by often I mean always, call our slant height this L. And we can say that the lateral surface area of our right circular cone is pi r L. R being again the radius and L being again the slant height. We use the same definition of slant height to just be the height of a pyramid, with one important detail change. Let's look at it. The height of a pyramid is the perpendicular distance from the base to the apex. Again, we remember that the apex is the point, okay? And it is important that we know in our pyramid, the height of a pyramid is perpendicular versus the slant height. If, for example, we had this cone, the slant height is just from the apex to any point on the base. But in a pyramid, if we had something like this, the height is straight down perpendicular to the base. A prettier picture you can find on page 22, which is where we are going next for our next example. Here we go. This is example 2.6 on that same page 22. The base of this regular pyramid, a regular pyramid is a pyramid with a square base. The base of this regular pyramid is a square with side length of 4 centimeters. We know that since it's square, all of our sides are the same. This slant height is 5 centimeters, and we want to find the surface area of this pyramid. Now, again, we know that the surface area of the pyramid is the area of the base added to the lateral surface area. The area of the base is a pretty simple one. The area of the base is side squared. We know our side length is 4, so it is 16 centimeters squared. Don't make a silly mistake like I almost just did. Then we look at, I'm going to redraw a face of the triangle. My pyramid face here is just a triangle. I know that the whole bottom is 4 centimeters, and I know that this height in here is 5 because it tells me the slant height is 5 centimeters. I can find the area of a lateral face. A lateral face just means it is one of the sides, and it's the area of a triangle, which is 1/2 base times height, which is 10 centimeters squared. In this pyramid, I have 4 lateral faces. So my lateral surface area, my LSA, is 4 times one of my triangles, which is 10 centimeters squared, giving me a lateral surface area of 40 centimeters squared. Therefore, my total surface area is the area of my base plus my lateral surface area, which gives me a surface area of 56 centimeters squared. Don't forget your units. Very, very important. Straight after this, let's move on to another example. This is example 2.7. Says find the surface area of a sphere with radius of 9 meters. Well, first, we need to learn about a sphere. A sphere is simply a perfectly round 3D shape, which that is what we are going to define by that picture. And we know in a sphere, all points on a sphere are equidistant from the center. Equidistant just means they all have the same distance. The surface area of a sphere is 4 pi r squared. And the volume of a sphere is 4/3 pi r cubed. Now, I want you to, in your notes, you should create a second portion of your notes on a separate page, and you should title it Formulas. And you should write out all the different formulas we have had from this lesson. Every formula from this lesson you need to memorize. You will not be given these formulas on your quiz or test. Now that we know this information, we can go back to our example 2.7 on page 23 and find the surface area of a sphere with radius 9 meters. So here is my sphere. Here is my radius of 9 meters. And simply the surface area of the sphere is 4 pi r squared. This is a simple calculator problem. We get 324 pi meters squared. This is an exact answer. It's exact because pi is still in it. Now, if I was to find the volume of the same sphere, the volume is 4/3 pi r cubed, which gives me the volume is 972 times pi meters cubed. Again, this is an exact answer because pi is in that answer. We want to leave our answers exact as often as possible because that allows us to have exact numbers. Exact is important because then they are not rounded. This is the end of lesson 2. We will go over questions and do homework in class tomorrow.